so far on the calculator? When it comes test time, you'll need just a regular old calculator. In other words, not a phone. So if you don't have one already, you might work on tracking down a regular old calculator and practicing with it to make sure you know how it works, make sure you're used to it. One thing we worked on in chapter 1 was negatives, right? So we wanted to make sure we know where the negatives button is on the calculator. A lot of times it's down towards the bottom. On the one I have on the screen, the negatives in parentheses. We want to make sure we distinguish, we know the difference between the negative button and the minus button, which is usually over on the side. It might have a plus/minus on it instead. So just to make sure you find yours and have it working correctly, how about you try number 1 here, negative 3,178 plus 792. On some calculators, you hit the negative button first. On others, you type the number in and then you hit the negative button to make it negative. Trying to find a good place on our screen here for the calculator. Ooh, that's not too bad. We're looking for an answer of negative 2,386. If you need any help getting that figured out on your calculator, just let us know. If it's working okay for you, maybe you try the next 5 or so. More stuff involving negatives. Like 397 plus negative 151. I'll fill in the first 5 or so answers and you can let me know if you need any help. You might need a little help tracking down the negative button. I put number 5 on here to remind me to point out that some calculators have parenthesis buttons on them, like the one I have on the screen does. So you could use those there. Or what's really going on between those two numbers? They're just being multiplied. Yeah, so a multiplication in between them would also work. You may or may not have the parentheses, no big deal either way. And I put the next couple on there to remind me to talk a little bit about fractions. You know, fraction bar is really just a division, so I just hit the division key when I come to a fraction bar. You might have a calculator that deals with fractions other ways as well, but you can always get away with using a division. And point number 8 and number 9 on here to remind me about the dividing when 0 is involved. You know, sometimes you can do it and sometimes you can't. Let's see what the calculator has to say. We want to put the top number in first, divided by the bottom number. Number 8, the answer should be 0. When we flip it around, notice what your calculator says. Mine says divide by 0, error. You might see something different. What we want to write or say, yeah, is undefined. So just try it on your calculator so you can see what happens when something is undefined. Anything we can help with so far? All right, well, we also worked with the exponents in chapter 1, so we want to make sure that we're able to square something and do other exponents as well. Squaring is so popular, it usually has its own button. So you might be looking for something like this one here, x squared. So I'm going to type the 25 in and then hit my squaring button. Then equals or enter to get my answer. So we're looking for something like this. Need help tracking that one down, getting it to work, let me know. If it's doing okay, could finish off that section. Number 11's in parentheses, but it wouldn't have to be. We can just square that if you don't have parentheses. Or if you do have parentheses, it wouldn't hurt to use them just to be sure. Sometimes the parentheses do matter, like number 12 versus number 13. You might recall in number 12, we're going to square the 5 and the negative, so that one should turn out positive 25. Whereas on number 13, we're only squaring the 5 and keeping the negative sign out front. So you might try and see how you can make sure you get those answers correct on your calculator. Because sometimes it'll try to outthink you. It's trying to outthink you. You're not getting these very same answers. You might have to approach it a little differently. If you guys need a hand there, just let me know. So that x squared button will work for squaring, but not for other exponents. We need a different button for other exponents. On the calculator I'm looking at here, it's this little rooftop caret symbol. Or other calculators will have more something like y to the x or x to the y. In either case, you probably type it in between the base and the exponent, so probably hit the 7 first, and then your exponent button, and then the 5. We're looking for an answer of 16,807. So poke around a minute, see if you can get that on your calculator. If you need some help, let me know. That's working okay. If you go ahead and try 3 to the 10th and 2 to the 20th. Sounds like a big answer. Anybody need a hand with the exponents on their calculator? Probably has an x to the y button. Okay. Yeah, that's definitely the right one. So put the 7 first, and then hit that button, and you'll put the exponent like the 5. Yeah, that's what you want. Sounds like you use it. Anything else you can help with so far? Well, down the road, square roots will also be a little bit helpful. You might have a button for square roots. On my calculator, it's up above the x squared button in kind of a yellowy green. So I need to hit that yellowy green second button. And then the x squared to get the square root to show up. Then I can type whatever I want underneath it. Your calculator might put some parentheses there. Wouldn't hurt to close the parentheses to make sure you get it just right. And sometimes answers don't show up as a decimal. So that's something I can also help with. That's not the right one. Let's see. We'd really rather have a decimal type answer, like this 15.811 and so forth. If we were doing something like that, we'd probably be given some instructions on how to round it, so maybe we'd round it to something like 15.8. So we're looking for a square root button or a square root symbol on the calculator. So I need a little help with the square root part. Well, let's keep the calculators handy from now on. Use them as we like throughout class. Chapter 1 is over, calculators are out. Let's flip back over to the front and see what we're getting into here in chapter 2. We're really building up to some more algebraic kind of topics. We kind of got the review sort of stuff out of the way. We're ready to roll. We want to be able to talk about like and unlike terms. Let me ask you to take a minute with these 4 pairs right here and maybe write like or unlike next to each one based on what you know so far, or maybe just making your best guess. Do you remember anything about like versus unlike terms? What are you guys thinking for number 1? Would those be like or unlike?
Dislike. Unlike.
Dislike or unlike? Yeah. Do you know what makes those two unlike?
They have different, like they don't have the same exponent.
Different exponents. Yeah, this first one here is just x to the first power, whereas this one is x cubed. Makes them unlike. What are you guys thinking for number 2?
Like.
Sounding good. How about number 3?
Like.
Nice. And number 4?
Like. No, not like.
Those are not alike. Yeah, unlike. Yeah, what makes those unlike?
Different letters.
Different letters, different variables. You got it. So what do like terms have to have? They have to have the
Same variable, same exponent.
You got it. Same variables and same exponents. Oops, can't spell the name. Variable and same exponent. Like 3x squared and 4x squared. In other words, all of this part has to be exactly the same. The only thing that can be different is the number out front, like the 3 versus the 4. Do you know what that number out front is called? It's kind of a big word. Starts with a C.
Coefficient.
Coefficient. Yeah. It is written on the top of the back here. Coefficient. So that 4 and that 3, those are the coefficients. Like in 3x squared, 3 is the coefficient. How would you define it? How would you say what that 3 is right there? A coefficient is what? Sometimes people say the number in front of the variable. Sometimes people say the number multiplied by the variable. I think either of those works. Do you know what the coefficient is in 4y?
4.
4, you got it. And how about in x to the 5th?
1.
Yeah. Sometimes we have invisible coefficients. And that makes it a little bit tricky perhaps, but as you get used to it, if you don't see a number in front of the variable, then it's understood to be 1. There's just one of those next to the fence. All right. Give you a second to get down what you want there. Then maybe we'll flip back to the front and try a little combining and a little distributing. Get us going. Anybody need to see this a little bit longer? All right. So back on the front side, where it says test yourself number 1, let's fill a few things in. For number 1, see what you know already about combining. Let's start with 9y minus 4y. And I'll fill in a couple more for you to try when you're ready. Maybe you're not so sure. Give it your best guess, or give it any guess. We'll talk it over in a minute.
Did you write 1 down for numbers 3 or 5?
Yeah, I did.
Okay.
There you go. Thanks. Answers for those on the screen. Why don't you see how you're doing so far? Then we'll talk a bit and make sure to get your questions answered. What you'll start to see or notice is when we have like terms, they can be combined. What we mean by combining is either adding or subtracting. Like 9y and 4y, those were like terms, so we can subtract or combine them to get 5y. Can you see where the answer came from? Where did the 5 come from? 9 minus 4. And what about the y? We just kept that, didn't we? Remember how we said for like terms, the variable part and the exponent has to match? Well, that's kind of like our unit. We'll just keep it the exact same when we add or subtract. Kind of like we did in number 3. 11x squared plus x squared equals 12x squared. Where did the 12 come from? 11 plus, there's one of those invisible ones, isn't there? So 11 plus 1 made the 12, and notice again we kept the exponent part exactly the same. In number 5, we have 4 different terms. They're not all like terms, but some of them are, like the 7y and the 2y, so we can combine those. That's where the 9y came from. And then the 6 plus the 10 are both just regular old numbers. They also qualify as like terms, so we can add them together to get the 16. Seen anything you'd like to ask so far about the combining ones, 1, 3, or 5? We're going to be working a little bit of distributing in as we go today, so wanted to just warm up on that also. What are you actually distributing in this first one, number 2? You're distributing the -2. So the -2 is going to be multiplied by the x and also by the +5. Makes a -2x and also makes a -10. So simplest way to write it is -2x minus 10. How about in number 4? What are you distributing this time? Definitely a negative. What if we want to think about it as a number? Think of it as negative. It's another one of those invisible ones. It's like a -1 times a 2x and a -1 times a -3. Maybe just thinking of it as a negative works for you, but if you need a number to work with, it's one of those invisible ones. Seen anything there you'd like to check on? Well, let's write down a little bit about how that works, and we'll practice some more. On the back there where we defined coefficient, we had room to write a little bit about combining like terms. By the way, sometimes people also call it collecting like terms, kind of like we did with the 9y minus the 4y equals the 5y. So in our explanation here, we really should say what happens with the coefficients, like the 9 and the 4, and what happens with the variables, like the y. What does happen with the coefficients? They get combined according to our operation here, right? If it said plus, we'd add them. If it says minus, we subtract them. So I'm going to say by adding or subtracting the coefficients. Just depending what symbol we have, plus or minus. And how would you describe what happens with the variable? Nine and the 4, we subtracted. The y's we just kept the same. Yeah. Keep the same variable. This one didn't have an exponent, but if it did, we'd keep that the same also, with the same exponent. Again, or it's kind of like a unit. It's like I had 9 apples, I took away 4 apples, I still end up with 5 apples. You had 9 y's, you took away 4 of the y's, you still have 5 y's left. So, do we want to practice some more combining, you think? Anything we definitely want to do a little bit more of, just let me know. Let me throw a next level combining question at you then. Let's try -2x plus 4 plus x minus 11. So we have 4 different terms there. Which ones of them are like terms?
Minus 2x of x,
Yeah,
and then 4 negative 11.
4 and negative 11. Good deal. So what about the negative 2x plus the x? What's that going to add up to?
Negative x.
Negative x sounds good. And how about the 4 and the minus 11?
Negative 7.
So altogether, that one's going to make negative x minus 7. There's something about the positives and negatives that give folks a little trouble sometimes. Let's see if you would be okay with this one also. 5y minus 3x plus 4x equals. So the like terms this time were the ones with the x's, the negative 3x plus the 4x. Since 5y is the only term like that, we'll just bring it along. Nothing to combine it with, so it stays the same. What would the negative 3x plus 4x add up to?
No less.
1x. You got it. And that 1 you can leave off, make it invisible. So when we're combining those coefficients, notice we want to look to the left. We're going to treat that 3 as a negative because of the minus in front of it. And add a 4 onto it. So it's negative 3 plus 4. That made the 1 for our 1x there. Anything you'd like to double check about combining or collecting like terms so far? So let's bring the distributing and the combining together. Notice in number 4 here, the instructions give us a certain order to do things in. It says distribute and then combine. In other words, if we distribute and get the parentheses out of the way, then we can see what like terms we have and we can combine them. So what needs to be distributed in this one? Can you tell?
The negative 3.
The negative 3. Yep, we need to multiply it by everything inside the parentheses. So we're just going to kind of ignore the 9 for a sec. See what's attached to the parentheses, and that's what gets distributed. So that 9 we're ignoring, let's just bring it down. And what we get from this distributing, the negative 3 times the 4 will make
Negative 12x.
negative 12. Good deal. And the negative 3 times the positive 1 will make
Negative 3.
negative 3. So I'm going to write those negatives as subtraction. We could put plus a negative. Eventually we want to simplify it to just minus.
6 minus 12x.
In other words, here's what's happening momentarily. Plus a negative, plus a negative. Now that the parentheses are out of the way, let's look back through and see what like terms we have. Like the 9 and the 3. We can go ahead and subtract those. 9 minus 3 makes 6. And then bring along our minus 12x. Since there's no other x terms to combine it with, that part stays the same. So distribute first, that gets rid of the parentheses, and then combine. Anybody would like to ask us anything about number 4? Let me give you a number 5. Let's try 12m minus parentheses 4m minus 6. What is it that you're distributing this time?
The negative.
The negative. Yeah, if you want to think of a number, think of it as a negative 1. Because remember, we distribute whatever's multiplied by the parentheses. So not the 12m, but the negative or negative 1. So the 12m stays the same. We've not done anything with it yet. The -1 times the 4 makes a -4, so I'm going to write it as minus 4m. And the -1 times the -6 makes a +6, so that'll be plus 6. Now that we've finished the distributing, let's see what we can combine, like the m's. So what will the final answer look like?
Minus 4 and plus 18.
Did you do 12m
No, I
minus
I
4m?
didn't do the,
8m
should be 8m plus 6.
plus 6. Nice.
I didn't put the m on the bottom.
Yeah. That makes it totally different, doesn't it? See anything we could answer for you about number 5? When we flip over to the next bunch, you'll notice it just says simplify. So they're not always going to spell out to us what we need to do, but our goal is always to simplify. And now this, what we just did, is the way to get started. Simplify for us right now means distribute and then combine. Possibly then that whole process gets repeated if there's more to distribute and more to combine. So simplify, distribute, and then combine. Just like we were doing. Oops. Hanging off the screen again. Sam, you gotta keep me honest. So let's see. Anything particular we just did you'd like to practice a bit more?
All of it.
All of it? How about to start with 20 minus 4x plus 6? And then we'll try 5 minus 3 parentheses 7z plus 1. Give you a minute to give it a try. Distribute first, and then combine. Just to check in real quick, what is it that you're distributing on number 1? Distribute the negative or -1. And how about on number 2? Distribute the -3. Nice. I'll let you get back to it. So distributing the -1 means I'm going to leave the 20 as is for now. 20 minus 4x minus 6. And then I'll look to see what like terms I have, like the 20 and the 6. So 20 minus 6 gives me 14. That was the only x, so we'll just bring it along. And we get 14 minus 4x. Or what would be another perfectly good way to write that answer? Because the 14 doesn't have to come first.
4x minus 14.
Yeah, 4x would have the negative with it still, so negative 4x, 14 would stay positive. Negative 4x plus 14, we can flip it around. We know that from the commutative property of addition, right? Either way we add, we get the same result. So 5 stays as is. Distribute the 3 to get negative 21z minus 3. The 5 and the 3 are like terms, so subtract them to get 2 minus 21z. Or what would that answer look like if you flipped it around?
Negative 21z plus 2.
Great. Either one of those are great final answers. How about some questions on those two? Well, let's build up a little bit more. Let's put negative and then a bracket, 5 and then a parenthesis, x plus 2, close the parenthesis, minus 7, close the bracket. Remember when we had nested parentheses inside of brackets before where we said to start?
Start in the middle.
In the middle? So in the middle, the most inside this time would be the x plus 2. Are those like terms? No. So let's just start to work our way out. And what do you think we should do about the 5 right outside there?
Distribute it.
You got it. So let's start by distributing the 5. Everything else stays the same. 5 times x would make 5x. 5 times 2 would make plus 10. And now inside of those brackets, do we have any like terms we could combine? Looks like these are like terms. So let's leave everything else as is. And let's add positive 10 minus 7. Subtract, I should have said, right? Let's subtract positive 10 minus 7. What would that make? Positive or negative?
Positive 3.
Positive 3. We've got our calculators now to help us out with stuff like that, right? Positive 10 minus 7. Now there's nothing else to do inside these brackets, so we'll work our way out again, and that negative is going to need to be, you got it. So negative or negative 1 times the 5x, and negative or negative 1 times the 3. We end up with a negative 5x minus a 3. So we just kind of repeat the process, starting with the most inside thing. We distribute, and then we combine, and then we distribute, and then if there was more combining to do. So our process, distribute and then combine. If we need to, we can repeat as many times as necessary to get it all simplified. So that one is there to kind of get us ready for a crazy looking homework problem down here in the special challenge section. Let's write it down and make sure we're ready for it. So we got some brackets here, and then a 3, parentheses, x plus 2, close the parentheses, minus 5, close the bracket, minus, and then we start a new bracket, 4, parentheses, x minus 1, close the parentheses, plus 6, close the bracket. It's kind of like a double vision or two of the problem that we just looked at. And that's kind of how we want to treat it. We really want to work on each side separately. So we'll work inside of that first set of brackets as much as we can from the innermost, working your way out. And then in that second bracket as much as we can from the inside, working our way out. Try starting on the left side. See if you can distribute and combine and simplify that as much as possible. Be sure and give it a try. Even getting it wrong is better than not going for it. What would be your first step over on that left side? Distribute the 3. You got it. If you haven't tried that yet, try starting by distributing the 3. Keeping the rest of it the same. Then we said after distributing, we'll look to combine. So we're looking for like terms in that bracket next to simplify it even more. Who could help me out with distributing the 3? What's that going to make?
3x plus 6.
Nice. And how about like terms inside that bracket? See anything that would be combinable?
The 6 and make 5.
So we'll keep the 3x. What is a plus 6 minus 5?
1.
So positive means a plus. And then we want to do that same kind of stuff on the right-hand side. So starting with some distributing. Keeping everything else the same for now. And then looking for like terms over there. Four times x, 4 times minus 1, like terms. Looks like that should come down to a 4x plus a 2. Sound okay so far? Now there's nothing else we can do inside of those brackets. Nothing to do in here or in here, but we do still have this minus out front. What do you think we need to do about that?
Distribute it to the right side.
You got it. So think of it as a negative or a negative 1 times everything that comes after it to the right of it. What about the first set of brackets? Anything we need to do to those?
Drop it down.
Yeah, technically, if anything, it's just a plain old 1 out front, so that's not going to affect it. We'll still have 3x plus 1. What effect will that negative or negative 1 have on these terms? It's going to change the,
So turn off negative.
turn them all to negative, change the signs. And now that those brackets are out of the way, let's look for our like terms again. And we'll finally be able to finish this thing off. So the 3x and the minus 4x are like terms, what will that add up to? The 3's positive,
Oh,
and the 4's negative.
It'd be negative x minus 1.
Negative x there, yeah, and then a positive 1 and a minus 2 add up to minus 1. Or if you had the minus 1 first, it looked like negative 1 minus x. There's definitely a similar homework problem. See anything you'd like to double check about it to make sure you're ready?